Hey everybody, Dr. A here. We are going to be exploring yet another right triangle trigonometry example in this video. So as always, you need to pick up your pencil and get some paper out, and you need to write all of this down step by step in a logical way. Remember, math is not a spectator sport, it is a participation sport. So the only way to learn and actually absorb what we're talking about is by writing it down and doing it yourself. So let's go ahead and get started. In this example, we are going to be given a right triangle, and we're going to be asked to compute the lengths h and w of the right triangle. Okay? And so the right triangle we're given is going to look kind of like this. And our right angle is up here this time. So if you notice, this right triangle is oriented a little bit different than what we've seen in some of our other examples. We're going to have this length over here is h, and this length over here is w, and then the hypotenuse length is 25 centimeters. So again, it's still a right triangle. Notice that you have a right angle inside of it. It's just rotated or oriented a little bit different than what we've seen in some of the other videos. You are also given one interior angle here of 35 degrees, okay? And so again, we're wanting to compute the lengths h and w for this right triangle. So let's go ahead and get started by writing solution. Now again, maybe pause the video or answer this question yourself. What can we always do to get one of these problems started when we have a right triangle? You can always go back to the basic definitions of sine and cosine and tangent as you need, okay? So let's take a look at this and remember, what is the basic definition of the sine of an angle? Well, if you remember, the sine of an angle is defined as the opposite side over the hypotenuse. And then, of course, the cosine of an interior angle of a right triangle is equal to the adjacent side, also divided by the hypotenuse of that right triangle. So basic definitions, we've seen this before, okay? So what can we do? How can we apply this to this particular problem? Well, first, notice that the angle you are given is this 35-degree interior angle. And you are also given the hypotenuse length. Now, again, how do we know that this 25 centimeters is the hypotenuse? Besides the fact that I told you, it's that the hypotenuse side is always on the opposite side of the right angle. So this right 90-degree angle, the hypotenuse of a right triangle is on the opposite side of that. So you see they're across from each other, all right? So we know the hypotenuse. We know the hypotenuse that's going to get built into both of these equations, okay? We know the angle that's going to be built into both these equations because we were given the fact that this is a 35-degree angle. So what we can make a note of is we can say that h, this length h that we're given here, is the side opposite of the 35-degree angle, and the side that has length w is the adjacent side of the 35-degree angle. All right, so how do we know that? Well, again, look at this 35-degree angle. What side is on the opposite of this 35-degree angle? Well, h is. And then what side is adjacent or next to this 35-degree angle? Well, it's this length w right here, okay? So what we can do is use this information to set up our equations. We can say the sine of that 35-degree angle, the sine of this 35-degree angle is equal to opposite over hypotenuse. So that's equal to h over 25 centimeters. And then we're going to put a comma here, and we can cross multiply this 25 centimeters to the left side of the equation. and we can say h equals 25 centimeters times the sine of 35 degrees. And when we solve this equation, I'm punching this in my calculator. 25 times sine of 35 degrees is 14.34 centimeters, and that's one of our answers. And then in a similar way, we can set up our relationship for cosine, and we can say the cosine of 35 degrees is adjacent over hypotenuse. So the adjacent side of this 35-degree angle is W. So we're going to have this is equal to W over 25 centimeters. And we'll say W equals what? Well, 25 centimeters times the cosine of 35 degrees. And I know that because I can cross multiply this 25 centimeters to the left side of that equation. And so when I use my calculator to say 25 times cosine 35 degrees, I get 20.48 centimeters. Okay, so a couple of things to observe here. Number one, I had units of measurement given to me based on the 25 centimeters here, and it's always good practice to include all of your units in your calculations. So these are built in all over the place here with final H and W values having units of centimeters. Okay. And the other thing that you need to keep in mind is our cross multiplication. We cross multiply the denominator of the right side of the equation over to the left side. So that goes back to maybe pre-algebra or algebra 1. And another thing to observe here is that we never actually used the tangent definition here because we didn't have to. We didn't need to use the tangent definition here because sine and cosine definitions is enough for us to solve what the problem is asking for. So that's going to conclude this video. If you like this video, go ahead, hit like and subscribe on the channel. Thanks.